Thanks, Joe.
Thanks.
Hi, everybody. Welcome to our live stream here on our MATLAB YouTube channel. My name is Tianyi. I am a product marketing manager here at MathWorks, focused on Simulink and Model-Based Design. And joining me today are two of my colleagues, Weiwu and Suresh. Hey, guys.
Hey, Tianyi.
Hey,
Hi,
Tianyi.
everyone.
So, Weiwu, do you want to start off by introducing yourself, and then we will switch to Suresh?
Sure. Thanks, Tianyi. My name is Weiwu Li, and the product manager here at MathWorks. My focus area is Simulink simulation capabilities, including Simulink Compiler. It's great to be here talking about sharing Simulink simulations.
Hello, everyone. Welcome to our live stream session. My name is Suresh Balakrishnama, and I'm a part of the. I'm also a product manager, just like Weiwu and Tianyi here at MathWorks. I'm responsible on the kind of the deployment side, which is how when you have generated something, for example, a simulation, how you're going to share with like others, and that's exactly what we will be covering in today's session. So thanks again for taking time to join us. Back to you, Tianyi.
Thank you, Weiwu and Suresh, for your introductions. It's great to have you guys on board today. We're also excited about having you join us today. And throughout today's live stream, we will be monitoring the chat and provide response to your questions. So please feel free to leave your questions in the chat as they come up. We'll also have a dedicated Q&A section at the end of today's live stream to have your questions answered. So please stay tuned. The topic for today's live stream is sharing your Simulink simulations. We will walk you through examples on how to do that. But before we dive into the details, let's first take a step back and talk about why do we want to share simulations. So let's say you have built a model in Simulink and you have run some simulations yourself. And at this point, you might want to share the simulations with a larger group of people. For example, your collaborators, your suppliers, or your clients. And these groups might not have the same level of modeling expertise or background as you do. Some of them don't have the same setup as you do. They might be using a different set of programming environments or simulation tools that are outside of Simulink. And they might not even have access to Simulink licenses. However, these groups will still benefit from the simulations by setting their own input parameters, running simulations, and obtaining results for post-processing and analysis. And this is where Simulink Compiler comes in. It helps you package and share your simulations in different forms of artifacts that you can readily share with a larger group of people so that they can access insights from your simulation as well, even if they don't have access to a Simulink license. An additional benefit of Simulink Compiler is that it helps you leverage your simulations for in-operation usage, such as building your digital twin applications. And with Simulink Compiler, you can also interface with other simulation tools and environments that are outside of Simulink. So that's an overview of the benefits that Simulink Compiler can provide. Now let's start out today's live stream by looking at a very specific example, the F14 flight controller model that is built in Simulink, as you're seeing here. You build this model, run some simulations on the model, inspect the results from the simulation, and now comes the time when you want to share the simulations with others. So I do have a question for you. What are the first steps that we can take to get started with exporting and sharing this simulation?
Actually, there's many ways you can share your Simulink simulations. For today's session, we're going to cover a few of them. First, let's start with the most popular option. That is, you want to share simulation as a standalone applications. In this category, actually, there are two different flavors. Let's go over those one by one. The first is what we call command line executables. So basically, you can run those type of simulation as a standalone application on your PC, because there's no GUI entry point. You need to use it from command line. This is quite popular. For example, you want to run simulation in batch settings. Okay. The workflow here is pretty straightforward. Let's say you have a Simulink model here. All you need to do is to wrap your simulation in a MATLAB function. Specifically, is the sim command. Then after that, you just need to use Simulink Compiler, MATLAB compiler to compile it. Then you will get the exe file. So here, just to give you like a better idea, I'm show you a simple example here. So let's move my MATLAB here. Okay. So of course, I want to make sure you know this is exactly the example I'm gonna use the model. That's what Tianyi just showed, the F14. Okay. Let's say if you want to share this as a standalone executables. Okay. So it's quite straightforward. First of all, you write a MATLAB function, let's say run F14 standalone. Then the first step is you need to specify this model and associate it with a simulation input object. This is quite important because if you want to deploy simulation, this is always required. Then you can do a bunch of other things. For example, you have tunable parameters, like inputs. You can use the syntax of simulation input object to set it up. Here, I'm just for demos purposes, I'm changing the gain of a no-pass filter. Then after that, you can configure your model for deployment. There's a bunch of kind of a check for you, just make sure your model is deployable. Then after that, of course, this is the famous sim command, right? Out equals sim in. Then after that, you can do a bunch of other things. For example, here, I'm going to show just in MATLAB, you can plot some MATLAB graphics, okay? So you may ask, okay, I have all those ready. What should I do to actually compile it or deploy it? So there's a couple of ways to do that. One is you can use the MCC command line here. You can type MCC, then do this. But I'm going to show you another way, kind of a graphic way to do it today. So what you need to do is to go to the apps, click here. Then you can see the application compiler. If you click on that, this window will pop up. Then you can see this will generate a standalone application for you, right? So all you need to do is just to go to this step to select the files. For instance, this is the run F14 I'm interested in, put it there. Then, of course, there's other settings where to generate this package, all those things. This package option, I think I'll just move it a little bit wider. To use a standalone application, you need to install MATLAB runtime. So here actually provides two options for you to choose. You either download from the web or you want to include in the package. Then here, of course, if you set up other configurations or the application information, then at the end, package it. It will generate the exe file for you. Just in the interest of time, I'm not going actually to package it, but I already generated exe file. So I'm going to show you how it works in action. Okay, so stop here. So as you can see, I already generated this run F14 standalone exe file. You may wonder, how should I execute this, right? So actually, I'm going to use open my command line window, right? If you already have runtime installed, you don't need to have MATLAB and Simulink run this little app. So let's just do this. Let's run this very quick. And first, you need to start MATLAB or all the things at the back end, then it will pop up, hopefully. If I say MATLAB, actually, I mean the MATLAB runtime. Sorry about that. So I was thinking there's no MATLAB in your desktop. So actually we'll see something like this, right? So that's exactly what you want to see if you run the whole thing in MATLAB. Okay, so that's the first flavor, is you can generate a standalone application, which is often used in command line settings. Then the second flavor I want to discuss here is actually is a standalone desktop app. In this case, you can actually use your simulation in a graphic environment, and you can use a MATLAB app designer to design the GUI. And the workflow here is quite similar to what we have shown to you before, right? You have Simulink model. You just wrap this into MATLAB function and compile it. The only difference is now you need to use that MATLAB function inside the app designer. Again, I'm going to show example here, right? So let's open my MATLAB and actually the app designer. So as you can see here, this is a very simple kind of a simulation app, right? You just have a simulate button. You have the same parameter I showed it before, is the no pass filter again. Then let's say generate the outcome, right? The panel false. Then there's look at the code, all right? So the really important piece is exactly what I showed to you before, is somehow you need to associate the model with the simulation input object. Then you need to set the parameter for which you would like to change, then configure for deployment, then run it, right? So of course, there's if you go back to the design view, you will see there's many other, graphic components you can add on this. Then you start from there, right? So that's pretty much the overall workflow for simulation apps.
Yeah. Just showed a pretty nice app like in App Designer, and if I'm like myself, like I'm not a super like an app developer, like so advanced software developer. Is there like a different way to create like these apps without having to know the entire like object-oriented programming and classes and things like that?
Yeah, definitely, Suresh, and I'm happy you asked that. This is an excellent question, and we actually have a thought about it. So I want to let you know about this Gen app feature, which can help you to create a simulation app without actually writing any MATLAB code. So it's really good. I want to definitely want to share with you here. So let's say if you have this F14 model again, right? You want to generate a really nice app, then you say, oh, as you said, I'm not comfortable with writing a bunch of MATLAB code, especially inside App Designer. So the best way to do that, actually, if you click on the Save button, at the very bottom, you can see there's like a simulation app feature. You click on that, it says it will click a simulation app from model. Okay. Then it has the preset multi-pane sim app template. Then it will give you the app name, and of course the definition. You can just create that. So again, just in the interest of time, I'm not gonna create this, but I'm gonna show you what it looks like after the creation. Okay. So let's go back to App Designer. It would be this. I already opened it here. So this is what you will get. Okay? It will, if you let's say if you have like a preview of this demo, it would be something like this.
And this is what it created for you using the model, the example the F14 model. Okay.
This ML app file is generated by the creator. I just skip that one because it takes a little bit of time. Then you can see on the left, it will have the snapshot of top model, and on the right, it will have all the tunable parameters from your model. Okay, so that's very nice. Then when you click this button, it's going to generate all the locked signals to show that actually I'm going to show it from like the deployed app. So I will go from there. Then you may ask, oh, I had this. How can I, actually compile it? So the nice thing is in the app designer is all integrated. All you need to do is just click the share button. Then at the end, it says standalone desktop app, right? Then you can do the other things. So I click on this. You will have this window exactly like what I showed you before. It will open this application compiler GUI here. So again, I'm going to skip this step. And I want to show you how it works. Like, for example, I already generated the exe file. I already actually installed on my computer. And look here, let's say if I type F14, this is something I've already installed. So I just click on that. It will open up in the background. So I just give a little bit of time.
That's good, Weiwu. That way, I think JetApp it's pretty nice, right? So I don't have to go take a separate software class like now to
Yeah.
like, right?
That's exactly the motivation here.
Kind of start out from your model and then create the app. That's pretty cool.
Yeah. So it all started here, as you can see. That's what. So right now, this is what started from the installed app, not the MATLAB app anymore. If you run it.
Maybe while you're just running this, one more question is like, so the MATLAB works.com, right? And
MathWorks website, you can go there, you can download it here. Yeah. So just one more comment here. Yeah, no problems. So just one comment here. This is like collapsible layout here. Let's say if you want to have two plot instead of one, you can, it just automatically it will plot those for you. So it's very handy and highly encourage you to give it a shot. And let's say if you want to customize that, you can just look at the source code of this. This is all generated, and then you can do stuff on your own and try to make it different if you prefer. So I think at this point, I would wrap up the first session. The most popular choice is you can share your simulation as a standalone application with whoever you are working with. So that's very handy.
Thanks, Weiwu. Thank you for showing us the workflow. So we have seen how you can export your simulations as standalone applications. You can run them either as standalone executables or desktop apps with a graphical user interface. And just as Weiwu showed us, I really like the Gen app feature because it provides a baseline app and you can directly have this app from your simulation model without writing any code. And if you do want to customize the app, you can use MATLAB App Designer to do some coding so that you can match your requirements.
That's right.
And that being said, what are the things that we need to pay attention to when using this workflow?
Yeah, I think the one thing I want to call out is you need to have the local installation of MATLAB runtime, right? You cannot skip that one. And make it even a little bit even more particular is you have to make sure the MATLAB runtime version is matching with the MATLAB version, which was used to generate this app. For example, if using, say, 2022B, right, of the MATLAB version, you generate an app. You want to, if you share this with somebody, you want to make sure that a person's runtime is corresponding to 22B. If it's using like 70A or something, more than likely it won't work. So that's pretty much the requirement here.
Right. So I guess now the question is, how can we make the end users' lives easier if they want to access the simulations? If they don't want to go through any of the installation steps, if they don't want to be concerned with, potential versioning issues. So Suresh, my question for you is that, is there another approach that we can use to share the simulations so that the group that you share your simulation with can access the simulation more easily without installation or, uh, thinking about versioning?
Definitely, Tianyi. I think that kind of, it's a nice segue and brings us into the MATLAB web apps. And so MATLAB web apps enables you to run a simulation in browser. Just now Weiwu showed like the desktop application and also a standalone executable, but you want to provide these to be accessible in a browser. MATLAB web app is the way to go. And the same, we use the app designer to create the app. And then the last thing I want to emphasize is the users who are running your simulations, they do not require like a software installer libraries, but to provision the web app server and create the app in App Designer, you can still you still need the a license and the server software. So kind of looking at the workflow, we have the model, and then app gets created in App Designer, which we showed in detail, and then you compile it as a web app instead of you already saw the options with standalone desktop. Now you compile it as a web app, and then it's available on the browser. So let me show you actually a running version of so here's a an example of a web app server. Each of these tiles is a web app. In fact, I can share this URL to all my colleagues here at MathWorks, and they just need a browser, which pretty much everybody has it, these days, right? So you just go to the browser and you click on one of these links, and it opens up, in another window. And here's my same the app which Weiwu earlier generated, and now I can go ahead and run the simulations, and this will show the exact set of plots which we saw earlier. The same set of plots will be showing up, and you can also go and modify any of these parameters here and and run them. So so that's the whole the benefit of running the web apps in a browser, and it's actually just uh-huh. Right. Yeah. So from the end user side, right, there's no particular requirement or restriction. They can run browser in any of the mobile devices or any operating system, and it'll just continue to absolutely run. There's no OS specific requirements from the end user side. I hope that's helpful. So here, I think it's coming up. But in the meanwhile, I'm going to just show how did we get to this point, right? You see the F14 simulation app is one of the app here. How do we get to this point? And so I have the same example here, which is the ML app, which Weiwu actually generated using the Gen app utility. So once I run this, I am going to I'm going to go ahead and run this, and this is going to just bring up the exact same app which Weiwu showed. Now, once I have this app ready to go, all the data and everything is ready. How do I make this as a web app? And this is where either the web app compiler, you could use the web app compiler to package all of these apps, or we even have build command line functions. Here's the app which is coming up, and so I can run the app and make sure everything works fine here. But then I also have the compiler. If you have like CI/CD functionalities, you can actually build like provide the command line instructions. So for example, right here you can see there is the web app packaging. It should be at the end here, and you can build this as part of your like batch scripts, right? So this is how you will generate the web app. So this is a GUI way of like generating the web app. Like you just have to provide the MLApp file and it'll package everything. So for just keeping for the time purposes, so this is the F14, the one with the file with the CTF is the packaged web app. It just has the app, it has the model, it has all the data, like everything you need to package it up, right? And once the web app package is ready, now let's like switch back to our web app server. The web app server will be installed, provisioned, and everything by your IT administrator, and the IT administrator can provide you the access so that you can go, if you have created the app, you can just go ahead and like upload directly from the browser here. And so the web app browser provides you that, the needed features to upload the app. So here I have the upload app, and I can just go ahead and like click on that, and that'll bring me the web app package. So once I upload that, now this will be available on the web app server. So whoever needs to run these things, run the app, they'll just go into the web app server and run it directly from the browser.
From the audience, the question is, can multiple runtime version be installed? It didn't say the context about it. Maybe it's related to web app server.
Okay. In fact, my screen went away. I'll come back to that. But you saw that there is yes, the web app server. The short answer is yes, it can support multiple runtime versions. What that means is that whenever you migrate your web app server version into like a newer version, the apps which have been developed with the previous versions of MATLAB and Simulink will continue to run. So here you can see I have a R2022B version running, but then I have any BE, etc. So that's the migration, and the ability to keep like what's running without having to recompile is a big benefit here in web app server. I hope that was useful, like to provide a context on how you can actually share your simulations, which then the other users can actually run it directly from a browser.
Yeah, thanks, Suresh. This is a great solution, especially for the end users, right? Because they can access the simulations by pointing to the URL to the deployed web app and then click on one of the web app tiles as you're showing here, Suresh, and then they can just run the simulations. And the process is as simple as that.
Absolutely.
So now we've talked about exporting simulations either as standalone desktop apps or deploying them as web apps. And sharing apps is definitely a great way of enabling a larger audience to set up, run, and analyze the simulation. However, sometimes other users would like to run your simulation as a standalone module in third-party simulation tools or environments that are outside of Simulink. So in this case, we probably need a different approach. So Weiwu, can you tell us if there is a standard for using simulations across different tools, and how does Simulink Compiler support this workflow?
Yeah, definitely. Actually, in this section, I want to introduce a very important capability of Simulink Compiler. That's to export your Simulink model as a functional mockup units. For those who are not familiar with this terminology, I just give you a very, very quick introduction. First, you probably heard is functional mockup interface, or FMI. That is two independent standards to support both model exchange and the co-simulation of dynamic models, including, of course, Simulink models here. Then another term you probably heard quite often is functional mockup unit, or FMU, which is actually the zip file with the extension name of FMU, which you package the model in the FMI format. So the FMI stand has been out there for a long time and it's quite popular, and it's currently supported by more than 100 simulation tools for either import and export. There's a lot of details about the standard itself, but in the interest of time, I cannot go to the details of that. But if you're interested, you can search those and read the specification. Okay, but I think the overall thing is FMI, or functional mockup interface, is a very popular specification out there to enable people to exchange their simulation components from one tool to another. Okay. Then specific for Simulink Compiler, what it does is it can enable you to export your simulation model as a co-simulation FMU, which is in compliance of the FMI standard 2.0. That's pretty much the most popular version out there right now. And you can use the generated FMU royalty-free in any third-party simulation environment. Okay, so the workflow here is pretty straightforward. Actually, not like to build a simulation app, right? You need to have like a MATLAB a function to wrap the simulation. Here, you can actually generate the FMU directly from your model. So with that, maybe I will just give you a quick, demo here. Again, let me move my MATLAB window here. Then let's say we are using the F14 model, right? So is the same I've shown to you before in the standalone app demo. If you want to generate FMU, actually it's very straightforward. Of course, there's a command line way to do that, but I'm going to show you the graphic way to do it. Okay. So again, just click on the save button here. And you can see just on top of the simulation app, you will see the standalone FMU, right? Then you click on that. It will pops up a configuration model. It looks simple. Actually, there's a lot of things on this configuration window, so I just go over this very quick with you. The first thing, the option you have is you can actually include the source code from the FMU. If you want to have a source code packaged in the FMU, you can click on this. And for some other very old simulation tools, for example, they don't support 64-bit DLL, they can only accept 32-bit, then there's extra option for those tools to generate 32-bit FMUs. Then you can here, if you click on this, you will see there's a list of all the tunable parameters of this FMU. Sometimes let's say you have 20 or 30, maybe hundreds of parameters. You don't want to expose all those to the end users. Then you have the choice to select which one you want to export, which one you don't, okay? Then another option here is calling the internal variable or local variable FMU. Sometimes you have this locked signal inside a model. You want to expose that internal variables, then this is the choice. But of course, here we don't have that. So another feature we have here is sometimes you want to, add more things to the package. For example, like a user's guide, your model description, something like that. You can add all those files if you want to. Then here we have another two options. You can generate the FMU only, or you can want to generate the FMU and the archived project with all the dependencies. So here you can just select that. Then the next one, of course, you just create that. And again, just in the interest of time, I'm not going to click it, but you can see I've already generated the standalone FMU here. Now, at this step, you may wonder what it looks like. Let's say if you want to run this in a kind of 30 minutes, okay? So here I'm going to show very quick demo here. So this is a third-party simulation tool. It is like basically FMPy is a Python-based simulation tool, but you can use any other third-party tool which supports FMI import, right? But here is really just for quick demo. I click this. Then let's say, okay, this is something else. Let's choose the F14 test.
Yeah, so when we use the generated FMU modules in a third-party environment or tool like this, do we need to install the MATLAB runtime?
Yeah, that's a really good question. Actually, I think this is maybe a little advantage of this FMU export. We don't need the MATLAB runtime to use the generate FMU. But again, I want to remind that may be also a limitation because we, in the version as of 22B, we only support fixed step solver FMU export. So maybe that's the reason, maybe technology-wise, we don't need to use runtime. In future releases, if we're going to support the variable step solver, then we might need to use runtime. So for now, yes, no, we don't need to MATLAB runtime. So let's back to this demo here. I think this FMPy, on the left, you can see all the tunable parameters here. On the right, you can see there's more information. Say the code simulation, and this is from Simulink, all those. Okay, let's just run those. Very simple. Yeah, you got your outputs, generate those. And again, this I use this as open source as just the tool as example here. You might have a very different execution environment if you go to another tool. This is just a demo. You could see very different things on another tool, right? I think that's pretty much the part for the FMU export. Tianyi, I think I would back to you now.
Thanks, Weiwu. So as Weiwu has showed us, exporting simulations as FMU modules enables you to integrate your simulation with third-party tools royalty-free. However, I might have some team members who are working with me and they're working with a different set of programming languages, such as Python, Java, or others. So Suresh, my question for you is that can they incorporate the simulation and even extend it in their programming environments or workflows?
Sure, Tianyi. You're giving me nice segues today. So absolutely, like, yeah, if you have like your fellow colleagues or other engineers or collaborators who are developing applications in different languages, you don't have to now rewrite what you've written in MATLAB or Simulink into some other language, or the person you're collaborating with, he or she does not have to rewrite in MATLAB. So that's a huge advantage. And so you can keep your code and you can still share, specifically like create a library for that particular language and share it with others. So this does require MATLAB for the user who you're sharing or the collaborator who you're sharing. What's kind of the workflow is, again, think about a model like F14 model, and then you can create a sim functions like within MATLAB, and this is what you've written. For example, it does takes a whole bunch of inputs and does a bunch of simulations. Now you want to share this with your colleagues who are developing applications in Python. Now, how do you do that? That's where MATLAB Compiler SDK, one of the products we have, that comes into picture. So all it does is it takes your the model simulation function which you have written in MATLAB, and you create that as a library. Here you can see that there's a support for a whole bunch of like languages, so you can generate language specific libraries. As simple as that. You provide the function, and this will pull up like all the dependency files, and when you run this thing, it'll create a Python specific installer, which you will hand it over to your colleague, right? And they will just install it just as any other Python library package. Once they install that, and in their code, they will import that specific sim underscore the model in their code, and then when they call, they will get the results just like you got it in MATLAB. So you have, I'm just showing a plot here. This example, it does a whole bunch of plots in MATLAB, but when the model, this particular model, is imported in Python, and it's when the Python code is run, you'll get the exact same set of plots in Python as well. So that's a big advantage here. You don't have to rewrite the MATLAB code which you've written. Don't have to start over, or don't have to learn like another language and go rewrite it. At the same time, on the other side, your colleague or collaborators, they don't have to go write in MATLAB. They can keep using what they have written, and this provides a nice interface and integration way that you can bring both the applications together. Does it help, Tianyi?
Yes.
Okay.
That's great. So just as Suresh showed us, we can export simulations as language-specific libraries to access and incorporate results from Simulink simulations with a different programming language like Python. So just to quickly recap, in today's live stream, we covered how you can use Simulink Compiler to create standalone applications that can be executed on the command line interface or exported as desktop apps with a graphical interface that allows you to interactively control and monitor your simulations, and you can even perform further customizations on the app with MATLAB App Designer to suit your needs. You can create and deploy the simulation as a web app with MATLAB Web App Server. And this is great because no installation is required for people to access the simulations. All they need is a web browser. You can export the simulation as a FMU module for co-simulation in other third-party simulation tools, or you can export the simulations as language-specific libraries so that the simulations can be integrated and even extended in other programming environments. And here are some additional resources to help you get started with Simulink Compiler. You can follow this step-by-step example that we demoed in today's live stream to export your simulations as desktop apps and deploy them as web apps. And please also feel free to check out the Simulink Compiler product page and explore more features that we did not have time to cover today. And there's also comprehensive documentation on Simulink Compiler and more examples to help you get started. And with that being said, let's take some questions from the audience.
I think the first one, Suresh, I want to start here is, does App Designer require a full local installation or just the runtime for execution? I think that we may want to differentiate a little bit, right? So it's a MATLAB app or it's deployed once, but
Yeah. So the App Designer, MATLAB App Designer itself is a part of MATLAB, right? It is a tool within like MATLAB. So if the question is around, yes, you do need to install like MATLAB itself to run App Designer. But if you are generating one of the targets which we showed you, and that you're providing it to somebody else, that the end user who's going to use your application, right? Like they don't need to install the full MATLAB runtime. In fact, there are features by which the application can know exactly which runtime components are needed, and it'll install it for them by downloading it from the web. So the end user who are using the the application you shared, yes, they do need MATLAB runtime to run those. But within MATLAB App Designer, or sorry, within MATLAB App Designer, if you're going to run the app, you don't need to have like runtime.
Yeah.
MATLAB
The design itself is a feature inside MATLAB, right? So once you deploy that, you are not deploying the app designer, you are deploying the app generated by the app designer. So just to make sure
that's right.
That's clear. Yeah.
Yep.
Yeah.
Yeah, Suresh, I think someone's asking a question regarding the web app. So they're curious about, are there any restrictions with the web security policy between app providers and app users? And some of them might include firewall and security programs.
So when you install with web app server, during the installation, it does need a certain port. Like I mean, there's a default port which gets opened during the installation, but you can always have a different port. But if your web app server is behind a firewall, yes, for the end users to access that, you will need to have that particular port on the web app server open through the firewall for it, for the end users to access it. Just like if you have any other applications running behind the firewall, how you open like the certain ports and do that, the same thing is applicable to web app server. There's no like specific restrictions like we enforce, but we, during installation, we walk you through. Want to make sure that the port for web app server is not either conflicting with anything else, or it's not opening up to like any other servers and systems. That is the one requirement we kind of advise you and walk you through.
It seems that we're getting a lot of app-based workflow questions today from the audience. Here is another one. So is there any integration of web apps with Atlassian?
Oh, that's a good question. So Atlassian, I guess there are the Confluence and like I guess Jira, like other things, right? Part of the Atlassian. So and those are all like browser based. So you can actually integrate call in a web app which is running on the web app server using, you can embed them as an iframe into your one of your Atlassian applications. So that way somebody who's looking at it, like is looking at a bunch of things, and then all of a sudden a web app pops up, like, right? But the server is still running somewhere else, and you're just embedding it like using iframe. So that's possible.
Nice. That's another question about the app designer, I think. The question is, can I use MATLAB app design for code generation? I think the question is like, if we build a app with app designer, somehow you want to, generate code from it. Is that supported?
So that'll be like if you generate code and you want to put it like in an embedded system, something like that, Weiwu, like, right?
I guess that's the
intention. So App Designer is not the right tool in that case. We have another product called as MATLAB Coder, and if you're looking into putting the code like in one of the embedded systems, MATLAB Coder is a better suitable product there. App Designer does not generate code.
I can imagine that's not the right way, because typically with App Designer there's a bunch of MATLAB graphics, right? So you cannot generate code to actually do that. So that's a good one.
But there's one question about around, can a FMI export be used in like a command line, kind of a non-graphic way? Let's say if they want to build it like in a batch system or things, is that possible?
Yeah, that's actually possible. I didn't show it in the demo today, but we have that. Maybe I will put it in the chat window. So we have the the API to support that workflow. So if you want to generate FMU from your model automatically way, in a model automatic way, you can do that. So that is supported. So let me put it here.
Yeah, I think there's also a question on whether we support Linux with a standalone desktop app approach with Simulink Compiler.
Yes, that is supported, but I want to make sure I understand the intention here. First of all, let's say if you are using Linux, right, with MATLAB Simulink, definitely you can generate an app in Linux for that. The second, sometimes people ask that question is really about cross compilation, right? I'm using Linux, I want to generate an app. Can that be somehow used with the end user who only have Windows access? Then the short answer for that is no, because we don't support cross compilation at this point for Simulink simulation deployment, but we are actively working on that feature. So maybe in future releases that limitation will be removed.
Yeah, so I guess if I create an app.
Just to add to that, like what Weiwu was, like, so if you are a model-based design engineer, or developing models and apps in future, you can continue to develop them in Windows, and like, for example, if the server where things are going to go in as web apps, that can be a Linux server, because most of the servers are Linux servers, right? Just to reduce the cost. So that that support will exist coming up, like in future, for sure. Sorry, Tianyi, I didn't mean to interrupt you.
Yeah, so just Weiwu's point, if you are working on a Linux operating system and you generate the app, you can share the app with someone who also has the same operating system platform as you do, right? But if someone else is using, for example, a Mac, then they will probably run into some issues running the app that you just generated from your Linux platform. So now, Suresh, there's a question on if there are any server requirements for web app server in terms of sizing.
Nice. So yes, like we do have a specific page which goes you through like different all the sizing requirements, and one of our moderators actually will can put the page for you, link it up. But overall, like in broad, if you let's say for every user who's accessing the web app, we on a high level we say about like a 1 gigabyte memory, and about 0.25 cores. So like a 4-core machine with a 16 gigabyte memory can support up to 16 simultaneous users. So it is hardware hardware dependent. So you may want to, and again, this is all like simultaneous at the same time, 16 sessions like running on the web app. So what I'm talking about. But if you have like 2 or 3 run at the same time, I think 16 gigabyte is like a plenty of like a server to support those users. But we'll provide you a link, like and that has specific that provides like specific on like all the details of like when it comes to like server sizing.
Right. So Suresh, you went through the sizing for the servers, and now another question is, for organizations who are moving their servers and systems to the cloud, can they run the web app server in their cloud environments?
Yes. In fact, we have solutions that are available for if you're moving into Azure or AWS, and we provide these cloud solutions. These are available on GitHub, and we call them as these are reference architectures. So what this allows is like you can click on a link click on those things, and this will actually help you deploy both web app server and everything you need in any of these cloud providers. So if you're new to the cloud, you don't have to think about like what to select and things like that. That is something guide you through with this reference solution. So yes, the short answer is we have cloud solutions specific for Azure and AWS, and in future probably for Google Cloud as well.
Any other questions? Or that's it?
Tini, the one thing is the example we presented and talked about in today's session. I think you did say that there was like a documentation page, and
Yes.
does it walk through all the steps? Oh, that's exactly one. Okay.
Yeah. So you can follow this link to check out this step-by-step detailed example on how you can generate, modify, and deploy the app from the Simulink model. And it has very comprehensive as well as detailed instructions for you to step through this example with specific commands. And this example also provides screenshots, so it makes it easy for you to follow along. And then at the end of this example, you should be able to have the app ready for deployment or further customization.
I think Suresh, there's an interesting question out there. Is asking the language specific target, right? You can do a lot of things like C++. There's a question: is a Fortran somehow supported? Fortran library, quite interesting.
Currently, we don't have support for like Fortran. Yeah, we do not have. I mean, those 4 languages you're seeing on the screen are the ones, and then you can also build like microservices. But if it is very specific use case, yeah, feel free to like get in touch. Either you could come to MATLAB Compiler, Simulink product page. You can get in touch with us, and we would be happy to kind of talk, discuss and see the specific use case. But right now, there's no support for Fortran and compiler. Weiwu, does Simulink compiler support FMI3 export? You may have talked.
Yeah, so that's a good question. As of today, for 22B, we do not support FMI3, but we do have the plan to support it in future releases. So that's something we're working on.
Great.
Because the FMI3 was just launched like last year, that standard. So we're taking a little bit of time to for us to support it.
Great. There's one more question. Maybe I think this is for you. How to simulate VANET communication?
Yeah, that's
you probably know more about it than me. So
yeah, that's a question. Yeah, it's an interesting one. Actually, MathWorks don't have like a product specific to support the VANET simulation, but I did see some users, they submit a toolbox, I think on their own to the file exchange. So I think I can put a link there. So if you are interested, you can test that out. But again, this is not a solution provided by MathWorks. So it's some kind of users that build on their own, but so you can test that with see whether that meet your needs.
I see. Oh, so there is like a discussion or some solution on the MATLAB, like MATLAB answers, like our
file
MATLAB
exchange.
answers community page,
right?
File exchange. Okay, great.
Great. Thank you, Suresh. Thank you, Weiwu. Today we have had a lot of good questions from the audience. And so please feel free to check out the additional resources for getting started. We introduce you to the examples, and then also check out the product page and the documentation for Simulink Compiler. And also, please subscribe to the MATLAB YouTube channel and stay tuned for more videos and live streams that are coming up very soon. With that, I would like to wrap up today's live stream. Thank you very much.
Thank you, Tianyi.
Thanks,
Thank you,
everyone.
everyone.
Thanks, Tianyi. Have a great day wherever you are.